let's go ahead and get started then. It looks like we have a number of folks in the room. Welcome, everyone. If you don't know me already, hello. My name is Annie Smith. I'm the Director of Energy Services for Ross Baruzzini. Today, I'm sitting down with John Biggs, who is our Senior Mechanical Engineer and Commissioning Agent. John has 24 years of experience in the HVAC industry. He first cut his teeth in the industry as a consultant engineer, then worked as a building automation controls programmer, followed by positions in facility engineering and operations at two local St. Louis landmark campuses, the Missouri Botanical Gardens and Washington University. He has now come full circle and is again working, thankfully for us, here at Ross Baruzzini as a consulting engineer for the last 1.5 years. So we recognize a lot of you in these trying times have already shut down your buildings or are concerned about the possibility of future shutdowns. So today we want to address things that should be done during a proper shutdown process to prevent future issues. Keep in mind, this does not include discussion on intermittent unoccupied operation, which would be typical to occur during normal building operation, but rather the situation where you have extended unoccupied periods. So this topic includes some action items that you can implement right now if you haven't already while you have your building shut down. And for those anticipating any future shutdowns, say potentially if there is a second wave of coronavirus, we hope to address some helpful information you can use at that time as well. If you find yourself needing to shut down the building again, or if you intend to keep some of your buildings shut down for a longer term. If you have questions during this webinar, please send them through the chat box so we can address them. We have folks gathering your questions and we will look at those once we get to the end. So let's get started. So John, as businesses continue to be shut down or opt to have their workers work from home or work remotely, how can building owners and managers use this opportunity to save some money related to energy?
Well, Annie, much of the energy-related cost of operating a building are related to the occupancy of the building, of maintaining comfort for the occupants, maintaining the environmental conditions, running the lighting, running all the equipment associated with the occupants. So there's definitely some opportunity for operational cost savings when a building is unoccupied, especially for extended periods of time. We really often look at trying to minimize the runtime hours of the HVAC equipment because that's in many climates, that's the one of the main driving costs of operating your building.
Okay, so how does one effectively minimize HVAC equipment operation? Most people are probably worried about mold growth and are afraid of reducing the run hours for their air conditioning.
That's a very valid concern. And of course, the worst thing we could do would be to just turn off all the equipment, shut the doors, and walk out. If any building operators have taken that strategy, you usually encounter quite a mess when you come back in the building. The goal here is to operate the building in its unoccupied period in a way that both minimizes any damage that can occur during that period, as well as reducing operating costs, and sets you up to be able to reoccupy your building with the minimum of effort. One of the significant costs, of course, of operating a building is bringing in your outdoor air. And when a building is shut down, you should really bring in only the minimum of outdoor air required to offset any critical exhaust and to keep the building positively pressurized to help keep infiltration of exterior air at bay. If you have an economizer mode, it's good to keep that enabled. Economizer mode allows for free cooling when the outdoor air conditions allow it. And of course, in the energy consumption world, nobody likes anything better than free in terms of getting the cooling effect. Some things you can do are turn off non-critical exhaust fans. Please note if the building is unoccupied, restrooms are now non-critical spaces, so those would be some very obvious fans to turn off. Additionally, exhaust fans often create a localized low pressure area that encourages infiltration, so you also get the benefit of reducing that effect when you turn those fans off. And of course, infiltration supports mold growth by bringing in moisture.
That all makes sense. And so speaking of high humidity and mold concerns, how can these be addressed in a way that gives building operators a peace of mind, but also saves energy?
Sure. So the key to preventing mold growth is to control humidity, to control condensation, and to not allow or to catch any breaches in the building envelope, whether that's open windows or roof leaks. If you can let the temperature in a building climb easily to 80 degrees if you control the humidity to 55% or lower. The cooling cycle naturally removes moisture from the air and dehumidifies the building. You can see that effect anytime you see the sweat off of a cooling coil. It gets collected, it goes down the drain, and that's how that moisture gets removed from the building. Typically, the cooling coil is controlled for human comfort. The alternative strategy for an unoccupied building is to control your cooling cycles to building humidity. There are ways to hardwire this to just use humidity sensors in parallel with thermostats so that the thermostat will trigger a cooling cycle when you're off set point, and that the humidistat will trigger a cooling cycle when the humidity requires it. A lot of buildings don't have humidity sensors. This might be something that you need to add. You install the sensors in a few key locations in the building to monitor the humidity. And again, when you cycle your cooling equipment to the humidity rather than to human comfort, typically you get a much reduced runtime hours and the associated energy savings.
Okay, so you mentioned 80 degrees specifically. Why limit the building to 80 degrees? Why not, say, let the building temperature climb higher in the summer? And then for that matter, is there a temperature that's too low in the winter?
Yeah, so for letting the temperature climb higher, it really depends upon the type of construction you have and the building contents. Often the building contents are the limiter. Extreme temperatures can have an effect on architectural fit and finish, especially if you have a lot of woodwork. Building contents affect the situation. If you have books, for instance, libraries, that kind of thing, the book bindings may be affected and dry out. If you have a lot of paper products, envelopes, that kind of thing can go a little awry. All kinds of interior adhesives at extreme temperatures start to go a little bit awry. They can get gummy at higher temperatures, or they can get brittle at lower temperatures. Generally, the low 80s is safe. If you want to go further than that, you just really kind of need to look at what you have and control appropriately. On the low side, of course, the biggest risk is freezing. I don't believe there's any such thing as removing all the water from a building. When you factor in your potable supply lines, the water heaters, possible chilled water system, your fire protection systems, all the drain traps, it's really very difficult to remove all the water from a building. And if it freezes, it almost always results in damage. And in the case of burst pipes, it can be quite extensive and quite expensive real quickly. For that, so I generally recommend, if you're not doing a sophisticated control sequence, that you limit the building to dropping to somewhere in the low 60s. If you want to drop it further, say into the 40s or even the upper 30s, there's additional factors that come into play, specifically that the dehumidification you get with the cooling cycle no longer kicks in when the building temperature is below the temperature of the cooling coils. You don't get the sweat anymore off of the coils. You don't get the dehumidifying effect. In that case, you actually have to heat the building up to drive the relative humidity higher. All this humidity control stuff is really the subject of psychrometrics, and it is a science. And again, if you're going at more extremes for your building control, I would really encourage building owners, if they don't have the internal resources, to get an engineer involved that's knowledgeable about psychrometrics. It's always important to have, even with all of that control, I would still recommend periodic inspection of the building by a live human being.
Yeah, that sounds like a good idea, John. I think from my understanding, it never hurts to just lay eyes on the building, lay eyes on the equipment. So I guess, on the topic of monitoring and having a physical human walking through the space on a periodic basis, what type of things should they be looking for as they're walking through the building?
Generally, you want to monitor the equipment rooms, make sure the equipment, still appears to be running. A perimeter check to catch any kind of open windows or breaches in the building envelope. If the building's vacated for a significant amount of time, open windows can really wreak some havoc on your building by allowing that untreated outdoor air in. One of the advantages of a human being over BAS monitoring is that human beings can hear things and see things that the BAS might not catch until it's too late. Rarely have I seen a BAS, for instance, that's configured to pick up on a roof leak. Also, human beings will pick up on things. Knowledgeable maintenance people can often, via hearing, hear things before they go awry. Compressors, pumps, anything that has a rotating bearing in it, for instance, will start to sound different before failure, and your human being can catch that before your BAS. Now, yeah, there are techniques of vibration analysis and monitoring to catch those things, but they are generally fairly expensive, and a lot of building operators don't have that kind of system in place. It's important. I'm sorry, Annie. One more note is that it's important for them to walk through at varying points, varying times of the day and night, to see that, for instance, that the equipment is actually shutting down when it's supposed to. If you go in the building at the same time every day, you're really only collecting data about that particular set of conditions. And so I do recommend that the walkthroughs vary.
Right, and that kind of makes sense considering what we're talking about. We're making sure that the equipment is cycling. So if you're only seeing it operate at the same time every day, you'll never see it in any other state. So that makes sense. And you mentioned the building automation system. Would having that reduce the need to have someone perform on-site inspections, though? You'd think that a lot of technologies these days can assist with sort of remote monitoring capabilities.
Yeah, absolutely. The BAS can monitor a lot more information, a lot more systems and points than a human being can. It, also, of course, has the ability to send out remote alerts via email, pagers, etc., to alert people when things happen that no one in the building is seeing. Again, the advantage of a human being being able to see and hear things that the BAS is unable to detect. BAS often has access to diagnostic codes. If you're looking at chillers, boilers, and that kind of thing, or variable speed drives, it can often give you a hint of what's going awry or which piece of equipment is going awry, so that if you call service personnel, they have some sense of what they should be looking at. Is a compressor locked out? Is it a flame failure on the boiler? Having those kinds of hints ahead of time, especially if the temperatures are extreme outside and there's the potential for damage, kind of having that heads up going into it generally is an advantage in terms of getting a rapid repair and a less expensive repair because you're avoiding some troubleshooting time.
Absolutely. Preferably speed things up when it's time to fix things.
Yep.
So getting off the topic of HVAC, what are some other things building managers can do?
Well, a lot of this stuff will seem, kind of like no-brainers, but it's worth mentioning. Of course, turning off any unnecessary lighting, turning off any non-critical equipment. You have your various parasitic loads, for instance, copiers, computers, printers, what have you, chargers of all sorts, whether they're power tools or electronic equipment, all draw phantom power, even when not serving equipment. So unplugging all that. Office refrigerators and ice makers, as long as you empty them, prop them open. We've all kind of seen the disaster at some time or another of a refrigerator left unplugged and closed. One thing that's worth mentioning, this webinar is not about restarting your building, but it's worth pointing out because it is a safety issue that buildings where the potable water is not being used, where it sits stagnant for an extended period of time, it loses its disinfectant chemistry that your water supplier put in it, and you can have increased risk of the growth of Legionella or other microbial issues. So during this periodic walkthrough, you can either have the maintenance folks, flush the toilets, run the faucets for a little while. If you don't do that, then when you reopen, definitely, do a flush of the potable water system. Really run the water, get the water heaters to empty and refill, what have you, so that you turn all that water over before you have your occupants consuming it.
That sounds like a great idea. And as far as turning everything off, what about excluding things like security systems, fire alarm, or any other life safety systems? And for that matter, do keeping the lights off present a security concern?
Well, of course, you do have to keep all your life systems operational, especially your fire protection systems, anything to do with life safety. I mean, literally, unless you're just walking away from the building, you're going to have intermittent occupants. You're going to have your potential facilities staff or security patrols. And so you do have to keep a minimum of not a minimum, you have to keep the life safety systems operational to serve them. As far as lighting and security, that's often, based on local experience. There are many operators who I believe rightfully believe that some lights on is one of the cheapest security steps that you can take. However, generally, I find that when you really look at a building, there are still lights that can be turned off. Or if you have access to a lighting control system, you can cycle lights intermittently to imitate building occupancy, and so still keep some lights going for security purposes, and yet also still turn some significant portion of them off to reap the energy savings.
Okay, so it sounds like when it comes to security, this should really be up to the decision of the building owner and operator, and whether saving the amount of money they could by turning off lights would be worth the additional risk.
Absolutely.
So, John, in wrapping this up, do you have any closing comments or remarks?
Well, certainly. Back to the beginning of the webinar, don't just shut it all off and walk away. That's almost certainly to be a disaster. If you're going to do any kind of more extreme temperature control, make sure you have somebody knowledgeable that is defining the sequences of control so that you kick your cooling on and your heating on at appropriate times to keep you out of the damage zone. Periodic building walkthroughs to monitor the equipment, maintain conditions. Also, you will still have the need to occasionally change filters, lubricate bearings, and that kind of thing, and that gives a natural opportunity for those inspections to occur.
Thanks for the advice, John, and for the valuable discussion. So now I'd like to turn to the audience and field some questions if we have some from the chat. Let me look over here. I'm currently not seeing any questions. That must mean that we got everything right and everything was crystal clear. I'm sure there might be questions later after everyone sits and digests all of this info. So with that, I will go ahead and wrap things up. However, I wanted to thank everyone for their attendance today. And I hope this discussion was useful to everyone. For all the attendants or all the attendees, we will be sending out a checklist summarizing our conversation today with items to keep in mind for buildings in unoccupied mode for extended periods of time. Um, Also, stay tuned for part 2 of this webinar series. We're doing a 3-part series. The next one is going to be where we focus on best practices for reopening your facilities. So look out for our notifications about that. And with that, thanks everyone for attending, and I hope everyone enjoys the rest of their day.
Thank you, Annie.
See you, John.